Hey everyone, in this video we're going to look at how to solve inequalities that have absolute values. These questions can seem a little bit daunting because you think you know absolute values, you think you know inequalities, but then when you throw them together it is pretty confusing. So let's start off with an easier example and then we'll do a trickier one after this. And I need to remind you how inequalities work in case you've forgotten. So x minus 3. If this had an absolute value sign around it, we're going to write this as a piecewise function to fully understand how the absolute value works. We know that absolute value turns whatever we have positive, right? So x minus 3, this will be positive when x is greater than 3, right? So if you plug in 4 minus 3 will be 1. If you plug in 5 minus 3 will be 2. So x minus 3 will be positive for every value of x that is greater than 3, right? But when x is less than 3, then if we were to put that into x minus 3, we'll start getting a bunch of negative values, right? So in order to turn those values positive, what the absolute value does, we just put a negative out in front of the quantity x minus 3 to turn it positive. So you can see negative times a negative number, since x is less than 3 in that case, will become a positive number. So you can see in both cases we're resulting in positive numbers. So really the absolute value is just, it's saying that this function will be different depending on when the inside of the absolute value is positive or negative. That's one way that you could look at absolute values. And that's a helpful definition for when you're approaching like algebra with inequalities and absolute value signs. So for this example, okay, we know that we've got two cases now. We've got when x is less than 3, and we'll start with that. When x is less than 3, well, the inequality, let's get rid of the absolute value and write it by what it actually will be doing. It's going to be negative times x minus 3. Since when x is less than 3, x minus 3 will be negative, we need to multiply it by another negative to turn it positive, since we have absolute value. And this is going to be less than 5. Now we can solve this like a very simple inequality. Negative x plus 3 is less than 5. Let's do 3 minus 5 is negative 2. And let's move the x to the other side, so plus x on both sides, and we get x must be greater than negative 2. And this is the solution to the inequality when x is less than 3. So the solution to the inequality when x is less than 3 is when x is greater than negative 2. So that's telling us that x is between negative 2 and 3. Okay? And the other case, we've got when x is greater than 3. In this case, we don't have to change anything to the absolute value. We can just drop the absolute value because it's always going to be positive in this domain. So we get x minus 3 is less than 5. Now we can simply solve this, add 3 to both sides, and we get x is less than 8. So this is now telling us that x is between 3 and 8. So now, to get the final solution, we need to look at both of our solutions, analyze these, and throw them together. So you may be wondering, so is it from negative 2 to 3, and then nothing happens at 3, like we need to combine both these domains, or can we just get rid of the 3 and then say from negative 2 to 8? And this will depend on the course that you're taking, I would say, because it depends on how the absolute value function is defined. So you can see how when we defined it here, if you look, I'm going to highlight both of our cases. We don't have any equal sign on either of them. It's when x is greater than 3 and when x is less than 3. From my experience in university, I've been in a course where they take the top bound as equal to or greater than, and they take the lower one as not equal to. And then I've also been in a course that I TA'd where they just didn't have a value at the cusp of the absolute value, and that's how I've written it in here. So in the case that nothing happens at 3, it's basically saying it's undefined, and in that case you would need to do from -2 to 3 and from 3 to 8 as your final solution. But if you're in a course where, let's say we've got this, and then we've got this, then in this case, then we would have as our final answer, x is just from -2 to 8. And this seems to make sense as well. If you were to plug in x equals 3 into the initial inequality, we get 3 minus 3 is 0. If that's defined, then you've got 0 is less than 5. That holds true. So in that case, you'd be from -2 to 8 as your solution. So let's move on to a harder example. In this example, we've got a rational function, and it's less than 1 minus, and then we've got another absolute value. So we've got inequalities, rational functions, absolute values. Pretty disgusting looking question. So in this case, it's easier to get rid of the rational function and multiply both sides by the absolute value of x plus 1. So if we were to do that, we'd be left with absolute value of x is less than 1 minus absolute value of x. I'm going to put this in some parentheses. And it's multiplied by the absolute value of x plus 1. Now, I just want to point out or draw attention to the sign here. We kept it as less than because we're multiplying by the absolute value of x plus 1. Remember, absolute values mean it's a positive number, always. So when we multiply both sides of an inequality by a positive number, we do not need to flip that sign. I just wanted to draw attention to that. So now, we've got two different absolute value functions here. And let's just write out the definition for both of them. First one will be a little bit easier to figure out. We've got x is just going to be straight up positive x when x is greater than 0. And then we've got x is going to be negative x here when x is less than 0. Because if it's less than 0, we need to multiply it by another negative. So negative times a negative will make it positive. We've also got the absolute value of x plus 1. If this were a piecewise function, well, x plus 1 is going to be positive when x is greater than -1, right? Start plugging in some values to check that if you're unsure. 0 plus 1 is 1. Negative half plus 1 is positive half. So anything greater, we're just getting more and more positive. And then we've got negative times x plus 1 when we have x is less than -1. Okay? So I'm going to draw a quick number line just to see what we're working with, and this is for the entire inequality. You can see that we've got critical points where our absolute value function will change behavior. And those points are at 0. Oh, actually, put that in the wrong spot. We've got -1 and we've got 0. So you can see here we have 1, 2, and 3 different regions where this inequality will change. So we need to consider all of these sections in order to find the solution, the general solution to our initial inequality. So let's do that. We've got x is less than -1 as our first region. This is region number 1. Let's solve for this right now. When x is less than -1, let's look at our our first piecewise function. -1 is when x is less than -1, x is clearly in the less than 0 domain, which means that absolute value of x will take on -x as its function, right? So we've got -x is less than, and now we've got the quantity of 1 minus, and we just said absolute value of x will take the form of -x. So -x right there. And now lastly, we've got the function x plus absolute value of x plus 1. When x is less than -1, this is going to be negative x plus 1. And that's just referencing those piecewise definitions that we wrote out for easy reference. I'd recommend always writing them down just to reference easier. You don't have to keep thinking about it over and over again. Okay, we've got now -x. I'm just going to do some algebra, simple algebra, expand these and simplify. We've got 1, we've got a plus x, we've got, okay, we've got 1 plus x, we've got -x minus 1, and this is going to be -x minus 1 minus x squared and another minus x. Two of those minus x's are going to cancel each other out. Boom, boom. And we can move things over. X squared plus x plus 1 less than 0. Great. And this was just, now we've just got a simple quadratic, and you'll see if you can't think of this visually, you can try to solve for the roots of the left-hand side, and you should figure out pretty quickly that there are no roots to this quadratic. It's always positive, and we're looking for solutions when that function is always negative. So there's no solutions to this. So what this is saying is that there's no solutions to our inequality when x is less than -1. That is the first thing we know. Okay, and a quick way to check that there's no roots, just look at the discriminant, b squared minus 4ac. All of those coefficients are 1. We've got 1 minus 4 times 1, so we've got a negative value. Negative discriminant, no solutions. Easy. Okay, so region number 2 now. We have got from -1 to 0. Or I should say when x is between -1 and 0. Well, we're going to do the same thing. We're going to replace the values of our inequality up here, and we're going to put in what behavior what function it will take on. Right? So when x is less than 0, an absolute value of x will be -x. So we've still got -x on the left side. Less than. And now this is 1 minus -x, so I'm just going to simplify this to plus x for now. And then we've got x is now greater than -1, which means that we're now just multiplying by x plus 1. Great. Same thing now. We're just going to do a little bit of math. Simplify this. We're going to expand everything. We've got, that'll be 1 plus 2x plus x squared. And simplifying this now, we've got 0 is greater than x squared plus 3x plus 1. Now, we're looking for the roots of this function, right? We'll see that the discriminant is positive, so we should go through with checking where the real roots are. So the roots, we've got -b, so -3 plus or minus square root of b squared is 9 minus 4ac, that's going to be 4 all over 2a, which is 2 times 1. So simplifying this now, we've got x, the roots are at -3 plus or minus square root of 5 over 2. Now you may be thinking, okay, I'm on a midterm, I'm on an exam, I'm not allowed a calculator. How am I supposed to solve this thing, right? And you can do a little bit of thinking here. And suppose that you had square root of 5 is close to square root of 4, and we know square root of 4 is exactly 2. So if we've got, let's just approximate, and we know that we're going to be close to that solution. It's not going to be exactly, but just to quickly check approximately where it is. Let's say negative 3 plus 2, that's going to be negative 1 over 2, so negative half. And that puts us right in the middle of the domain that we're actually caring about. Remember, we're only caring about the solutions here between negative 1 and 0. And one of these roots is like right there. So if we had square root of 5, which is just a fraction over that, and then we're dividing that by 2, then it's going to be pretty close and slightly in this domain. So if you don't have a calculator, that's how you could figure that out. Looking at the other root, if we have negative 3 minus and then approximately 2, that's going to be like negative 5 over 2. That's like negative 2.5. And that's very clearly pretty far away from that domain. So we don't care about that root since the actual root is probably not going to be in that domain. So we care now about negative 3 plus square root of 5 over 2. And we want to keep this as in its full exact form because we want full marks for communication. Okay, so now just looking at this, there we go. So we see that the quadratic is positive, which means it's going to be shaped up, right? Shaped up like this. And it's going to look something like this, right? Something like that. And we care when it's positive, right? So this is, let's say this is negative 1, and let's say this is 0, because this is the region that we care about right now. So clearly, we're looking at this region, everything to the right of that root. So the solution just for region number 2 now would be when x is between the root that we found, negative 3 plus square root of 5 over 2, and 0. Great. Now let's move on to the third root. Third region, sorry. Okay. So region number 3, this is when x is greater than 0. Okay, let's take a look at that. So we've got when x is greater than 0. Okay, well, all of the absolute values in this case are going to be positive, right? Same thing, same process that we've done with the other ones. And in this case, our inequality will become x is less than 1 minus just x times, and now it's just going to be x plus 1. Okay, and might be getting a little bit repetitive now, but we're almost done. So we've got x is less than, we're just going to expand this out. We'll get 1 minus x squared. Simplifying this, we got x squared plus x minus 1 less than 0. You can solve this however you'd like. And solving this for the roots, we'll find, so solving the roots, we got this value, same exact process, just used quadratic formula. And we can see that we took the positive root in this case because we're in the region where x is greater than 0, right? We were in region 3 of that number line that we drew at the top. So now looking at this inequality that we're looking at the roots of this quadratic for, we see that that function will be, we're looking for the regions that it is negative, right? So if we were to draw this out, right, then we will see we would see that one of the roots is going to be negative, because -1 minus square root of 5 over 2 is negative. The other root we know is positive. So it's going to look something like this. And we only care for when x is greater than 0 and it's less than that root, because we're looking for the negative part of that function, right? So in this case, we would see we're looking at from 0 to that root on the right side. And that would be the solution to just the third part. And then finally, we want to take all of the solutions. We want to look at all of the solutions that we found and put them together for our solution to the general inequality that we found. Okay, so let's take a look here. First one, easy, no solutions, great. The next one we've got from -3 plus square root of 5 over 2 up till 0. The next one we've got from 0 to -1 plus square root 5 over 2. So that's pretty good for us, okay? We can see that there's solutions from these weird rational numbers to up until 0, and then from 0 to that other number. So you could just take the union of both these domains, and that would probably get you a lot of marks for the question. And again, it comes back down to how the absolute value function is defined for the course that you're taking. So if it was equal to each other, then we know that at 0, we'll just look at our first initial inequality. 0 over something that is defined. So we've got 0 on the left-hand side, and it's less than 1 minus 0. So 0 is less than 1. We know that at 0, everything holds true. So if the absolute value is defined at that cusp, then we could just say that the solutions would be from the first root, which was -3 plus square root of 5 over 2, up until, and then 0 is, it's inclusive, right? So then we would have -1 plus the square root of 5 over 2. And finally, you're done with this disgusting inequality question, and hopefully you never have to do this again.